Okay, so let's try to understand what are the key differences between chat models and reasoning models. The difference is very simple actually. The main difference lies in the training data and the training architecture. So, chat models are also sometimes called as referred to as base models. Uh, Chat models are very, very simple and straightforward. As I've explained in the previous sessions or previous lessons, you take a certain word and then you predict the next word. The training is very, very simple. What they do during the training phases, they'll take this particular sentence, they'll mask this piece, and they will ask the LLM to predict that particular token. And if the prediction is correct, then it will move on to the next word. If the prediction is wrong, then the weights and parameters will be adjusted. This is a very basic way of creating an LLM models, and this is what we have been following for quite a long time. But Claude has done something remarkable. And after that, many people have started adopting the same thing. And it's not a very easy thing, actually, to be honest. What they did was they took a sentence, they masked the final output, and they've let the LLM model predict the actual placeholder, whatever is going to come in that place. Then they have a separate evaluator, discriminator, or let's call it evaluator. So what this evaluator does is it will check if whatever has been filled in that slot is correct or not. It will check if it will evaluate if this placeholder, whatever it has filled, is correct or not. Depending upon how right or how wrong it is, the actual LLM model is going to receive either a reward or a punishment. This is what we call as reinforcement learning. And this is actually a technique that we have previously observed during GAM, uh, GAN actually, Generative Adversarial Network. So this is how the stable diffusion has actually started. So before we had stable diffusion, we had GAN, Generative Adversarial Network. This is like the grandfather of AI image generation. And in GAN, we use the exact same thing. We have a generator and then we have a discriminator. Generator will create an image. The discriminator will check if whatever it has generated is correct or not. If it is correct, good. If not, it will punish. If it is good, it will reward. If not, it will punish. We are following slightly similar approach here as well. We have an evaluator and it will check if the actual output is correct or not. But this artificial intelligence is transforming industries is a very bad example. I'll try to give you a very good example for a reasoning model. 2 plus 2 is dash and it is filled with 4. So the LLM is giving 4 as the prediction. Now the evaluator is going to check if 4 is the correct answer or not. How does it know if 4 is correct answer or not? There are two ways. One is depending upon the actual training data. So let's say if you're using a very mm, complicated math related training data where you have one problem at the top, 20 different steps, and the final output. The LLM model is going to predict all the different steps, then it will predict the final answer as well. Now the evaluator is going to check LLM prediction with the actual mathematical equations, the actual math steps, the correct ones. Based on how correct or how wrong it is, the weights and parameters will be adjusted. The reward and the punishment system will be implemented. Because of this reason, the LLM will become a master, not a master, but at least really good at solving problems which require step by step analysis. So this applies not only for maths, but also any sort of educational or teaching sort of things where you need a step by step approach. or anything that requires a proper planning. So let's say if you're doing a sprint planning, or if you want to create a product project roadmap, these are the different things where you need to plan things first, and then for each item in the plan you need to write a separate to-do list or a task list or a step-by-step output. So in those kind of situations the reasoning models are much more better at performing. But if you give a very simple task like casual chit chat, they are not the best at doing that. Of course, you will get an output. If I ask a reasoning model, you will get a output for sure. If I ask it to tell me a nice poem or a funny joke, of course it will do it, but it is not meant to be used for that purpose. Because they are reasoning models, their architecture is slightly different. They will consume more power, and they are designed for achieving tasks which are really huge. So things like solving a maths problem or uh, creating a plan, like a diet plan or anything. These are the different things that reasoning models are good at. So if I go back to this list and training focus, yeah, you can see the primary goal for chat models is smooth, engaging conversations. But for reasoning models, it is accurate and step-by-step problem solving. And the response style is always going to be very polished, concise, and friendly, of course. But in reasoning models, you cannot observe that. So if you have a paid subscription for ChatGPT, you can compare it. You can ask the same question for GPT 4.1 or GPT 5. The response is going to be very nice and friendly with emojis and everything. But if you ask the same question to a reasoning model, Claude 3.7 is a reasoning model. Claude 4 is a reasoning model. 4.1 is also a reasoning model. So if you ask simple casual conversation kind of things for a reasoning model, they will give you a response, but it is not going to be friendly. It's going to be strictly business. And handling ambiguity, whenever you ask something which the chat model is not completely sure about, it will ask you those questions. But the reasoning model, it will just perform the task for you. It will do it and it will give you whatever you have asked for. If something is not correct, then you can ask it to redo the task once again. So let's say if you have given it some math problem, it cannot ask you to help you with the formulas or help you with the approach or anything. It will just write all the steps. It will give the final answer. It's up to you to decide if the answer is correct or not, or if you want to use that blog or not, or if you want to use that sprint planning or not. So that is the key difference between the chat models and the reasoning model. Next, there are three other small differences, not small, but definitely considerable, which is speed. Chat models are way more faster compared to reasoning models. And since reasoning models are used for specific purpose, OpenAI or Claude or any other thing, they take their own time to improve the model's output properly. So they will write in the system instructions saying you need to ask the user and these different set of questions depending upon the task, of course. So you need to ask the user for more confirmation before you give the final answer. But in chat models, you don't have that. If you ask a question, it will directly give it to you. But in reasoning models, whenever you ask it, like create a front-end UI for a food delivery app, it will not go ahead and create it. It will ask you for certain small clarifications. Next, we have error recovery. Now, this is something that we are going to cover in one of the upcoming lessons where we are going to cover different prompt engineering techniques. Over there, I'll explain this in detail. But essentially, the chat models, they don't go back and check what they've written, but the reasoning models, they will actually take a look at what the previous predictions were before giving the next predictions. And best for like customer service, tutoring, brainstorming, simple tasks. But the reasoning models are much more suitable for math, logic puzzles, coding challenges, whichever requires a lot of thinking and reasoning. So these are all the different things that you have to understand when we're working with chat models and reasoning models. For basic chatbots, we usually just go with the chat models. Even in the AI Foundry also, you can find many different models which are chat only. And also you'll find many different reasoning models. If I try to go to portal here again, let's go into deployments. Here you can see mini, nano, and chat, GPT-5 chat. Similarly, you will have O1 mini, which is a reasoning model, enhanced reasoning and problem solving on Azure. So these are the key differences between the chat models and the reasoning models. In the next lesson, we are going to cover advanced prompt engineering techniques, and this is going to be very, very interesting. We are going to try different prompting directly in ChatGPT. See you in the next lesson.